We can paint the world a beautiful picture, holding out for everyone to view.
We are taking notes this evening on remarkable relations and fanciful functions. Now, these two things, relations and functions, are related to one another, but they're not the same. So I like to think of it as a function is always a relation, but a relation may or may not be a function. Okay? A relation is just a set of ordered pairs. Excuse me. Sorry, guys. All right. So a relation is a set of ordered pairs, and the domain is going to be your x values, the x coordinates in the ordered pairs, and the range is the y coordinates in the ordered pairs. And you have 4 different blanks there, so I'm going to give you 4 different ways of describing domain and range. The domain is also known as, here's some vocabulary for you. It is, first of all, the set of x values. It's called the abscissa. Okay? New word for you. It is the input, and it is the independent variable. Independent. And we're going to talk a lot about that when we graph functions. The range is known as the y values, the ordinate, the output, and the dependent variable. So the dependent variable obviously is based upon what happens with the independent variable. Now the easy way to remember these, because you do need to know these words here, is that x comes before y, abscissa comes before ordinate, input comes before output, and the only one that's different is the last one. So you're just going to have to be careful there, okay? Because that doesn't go with domain and range. Domain comes before range, D before R, X before Y, A before O, I before O, and oops, the last one fails. All right, sorry about that. All right, so given the relation, find the domain and the range. So we set it up as a set of values. The domain is all of your X values, and the range is all of your y values. Okay? We can write our relations in 3 different ways. So, actually 4 different ways, because we can show the table that shows all the x and y values. So, that actually is your first one. Tables with your x and y values. You can do a mapping, so see 2 maps to 1, -1 maps to 3, and 0 maps to 4. Or you can actually graph the points. So there are tables, mappings, and graphs. So if we look at the following table, and you guys should go ahead and take a look at how to do this, you are going to give me the set of ordered pairs. When it says show the relation, I want the set of ordered pairs. I want you to give me the domain, the range, and a mapping. So pause the video and go ahead and solve that. All right, relation, it's going to give me the set of ordered pairs that I see there. The domain is all of my x values. The range is all of my y values. And for a mapping, I get this. Okay? -1 maps to 3, 0 maps to 6, 4 maps to -1, and 7 also maps to 3. Let me go back here. I'll go back there quick so you can pause it if you didn't get that. Okay. And moving on. We don't need to write the 3 twice here in this mapping, okay? Just a little FYI. So what is the domain of this relation? You should be able to give me that answer pretty quickly. And I get, it is 3. So again, I don't need to write that 4 twice. Got it? The range of the following function, number 4. All right, inverse. This is just a vocabulary word, and the inverse of a relation says for every ordered pair, x, y, there must be another ordered pair, y, x. So it's just saying if you want the inverse of a relation, you switch x and y. So to write the relation, I'm just going to write the set of ordered pairs. You guys should do that. And then to write its inverse, I'm just going to flip them around. All right. So the actual relation itself is going to be your set of ordered pairs. And then the inverse is just going to be that set of ordered pairs with the x and y's reversed. Okay? Now, here you get an opportunity to write the inverse of this mapping. As you can see, it's x paired with 4, x paired with 3, the same number paired with 4 different numbers. So my y's would all be that number, which is example 1. Now we're going to talk about functions, and functions are very special relations. They are a relation in which each element of the domain is paired with exactly one element of the range. Another way of saying it is that there is one and only one output with each input. So that's saying that x cannot be paired with 2 different y's. So the example that we just saw was not a function where it had -3 paired with 4 and -3 paired with 3 and negative. X cannot be a 2-timer, okay? X cannot be paired with different y's. Function notation looks like this, and what it's saying is I put in something for x and it outputs something for y. So function notation is the same thing as this f of x, y equals f of x. All right, that is function notation. So if you think about this, that should go in the little box there, okay? Y is your output. Remember our function box that we just saw. Y is the output. F of x, that's the name of the function. You can have f of x, g of x, k of x, q of x, r of x, anything. Okay, that's the name of your function. And your input is x. So let's look at whether each of the following relations is a function. Remember, you're testing for x. Is it paired with different y's? In the case of the first example, I have 2 with 3, 3 with 0, 5 with 2. Okay, I have all different x's, so it looks like it's a function. All right? They're all paired with different y's also. So this is a function. The next one. See what you think there. Now you should be saying, something's wrong, something's wrong. This has 5 paired with 2 and 5 paired with 3. That is not allowed. It fails being a function because 5 is paired with different outputs, okay? So this is not a function. And the third one, 1 with 3, 2 with 3, 3 with 3. Now this one some students get confused with, but the reality is it is a function. It is x that cannot be a 2-timer. Y can do anything they want, okay? Y's can be paired with different x's, but x cannot be paired with different y's. There is also another test. I want you to do the 2 mappings on your own. So circle 4 and 5, you can do those on your own, and we'll check them tomorrow. Okay, so let me know if you think those are functions. All right, we have another test for telling if a function is if a relation is a function, and we have this test is used when we are looking at the graph of a function. Okay, remember that we looked at graphs. And I want to be able to tell if they're functions. We have what we call the vertical line test. And basically what happens if any vertical line passes through more than one point of the graph, then it's not a function. So I'm going to draw a vertical line, and it can only hit my graph in one place. So obviously anywhere I draw a vertical line here, it's only going to hit my graph in one place. That's a function. The next one, a parabola. Yes, that's a function because anywhere I make a vertical line, it's only going to hit my graph in one place. The circle, unfortunately, is not a function, okay, because you can see many of these vertical lines go through our graph in more than one spot. So it is not a function. All right? Let's look at these. Is it a function? Sure, that's a function. Now, we're also going to talk about the domain and the range for this. The domain of this, if it had arrows, which it should, okay, would be negative infinity to infinity. The range, what are my y values? The y values are 2, and it does pass the vertical line test, so it is a function. The next graph, that is it is a vertical line itself. So there's an infinite number of ways that it fails the vertical line test. My domain in this case is 2. It only takes on the 2 value for x, but the y is negative infinity to infinity. The next graph is a sideways parabola. And if you look at the vertical line test here, it is going to fail. All right, because there are several places where the vertical lines hit the graph in more than one spot. Now, think about your domain and your range. Does it take on any values to the left of negative 2? No. So my domain is going to be negative 2 to infinity, assuming this has arrows. My range, interestingly enough, is also negative infinity to infinity. It appears that it's not going to go that high, but if you consider how big infinity is, then it will eventually get there. Okay? And this is a cubic, and the domain is negative infinity to infinity. The range is negative infinity to infinity. And is it a function? Yes, it is a function. Okay? All right. So, we already did that. Okay, so hopefully we've got that. Is this a graph of a function? This one's not on your paper, but what do you think? Sure. Okay, it passes the vertical line test. Now, you have some examples here. I'd like you to pause the video and try to figure out what these are. Okay, so f of 3, you're going to plug it in, pause the video, okay, and come back and check it. Is 3, goes in, I multiply it by 3 and subtract 2, and I get out negative 7. Sorry. The next one, f of negative 2, goes in the function, comes out as negative 8. Okay, now we've got an h of z. So it doesn't have to be x. We can be taking the function h of z and plugging in, solving 30. And g of x, plug in, f of x again. This one's a little tricky. You got to do f of 3 minus f of 1. So you do the f of 3 part first, get an answer, subtract what you get once you do f of 1, and you should get negative 16. Okay? So I'd also like you to practice that last section of the notes, and we will continue with functions discussions tomorrow. Have a great night.